chart that they give you, you can generate that with your calculator, correct? Now, it might be worth it on the exam, just like right when the exam starts, just jot this down so you don't have to like bounce back and forth between the chart and the screen. That might be an option for you. Some of you want to keep it, that's okay too. So we talked about this on the whiteboard before we started. 20 is the same as 4 times 5. Like, why don't they choose 10 times 2? Because 10 and 2 is not on this list. This list over here. Do you see that 4 is on the list? 4 goes right... wrong one. 4 is here. Okay. So then what they do is they split the radical in this step. And then they simplify the perfect square. The square root of 4 is 2, because 2 times 2 is 4. And then you just rewrite it like this, 2 root 5. Let me get off these marks, and there it is. That's pretty much as easy as they come, because there's only one option, and 20 is a pretty small number. It gets harder when like it's really big numbers and there's more than one option on the chart to pick from. Okay? Or if they put fractions in there or stuff like that. Alright, now class example 6 is going to show you that if you don't choose the highest one, then you run into problems. So for this one, you can put a little note. Choose the largest perfect square factor. And we actually did this one on the board because 72 demonstrates this perfectly. Like we did this one already on the board. 72 is the same as 36 times 2. Which one of those is perfect? The 36. So then the 36 becomes 6. And the root 2 is not perfect, so you just leave it in there. You just leave the 2 because it's not perfect. So 6 is just a regular old integer, and the square root of 36 is a perfect square. Perfect squares become rational like that, and the non-perfect squares are not. So like what if I used 4 instead? Could I use 4? Is 4 times 18 72? Yes. So then, what's the square root of 4? 2. So then, you just keep going. Now you look at 18. What are the factors of 18? Yeah. So 18 becomes 9 times 2. Like, why didn't you choose a different factor? Like 6 times 3 is also 18. Why don't you use 6 and 3 here? Because they're not perfect. Good. And then what's the square root of 9? 3. Yeah, and then that becomes 3. Yeah, and then you put those together. 2 times 3 is 6, and you end up at the same thing. It just takes longer. Yeah. It just takes longer if you don't choose the largest. Okay? So that example just demonstrates you must choose the largest one to minimize the amount of work. Yeah. All right, so let's try these ones. The square root of 160. So this, I'm just going to whip out the calculator for this. 160 is a kind of a weird number, right? Now I know what the answer is because it's not that big, but this is the process. If I was confused, this is what I would expect a student who's done their home. Listen for me. Thank you. This is very important. Just do this. Oh, 4 works. Oh, 9 does not work. 16 works. This is called like systematic like checking, like one by one. It's slow, but it guarantees success. Like, what's the next option? 25. I'm just choosing them off the list. Now I'm starting to get a feeling that the numbers are getting too big here. But just to be sure, I'll try a couple more. And I'm thinking, I don't think, like, what's the next one on the list? 81? Like, that's now too large. Like, so what was the best option there? 16. Good. Okay, and did you see also that 4 worked? But just go with the largest one that worked. So I will change. Okay. I like to actually break it down like a factor tree. That's what I like to do. But it's up to you what you want to do. Like, and I like personally to put the perfect one first. Like, why would I put the perfect one first? It goes to the front left anyways. Excellent. And the square root of 16 is 4. Excuse me. So there's that final answer. Yeah, this is 10C. Yeah, for sure. You've done this before. Oh, and maybe 20-1 if you're in there as well. Okay, let's do the next one. 98. Like, I know this one too, but I'll let you guys, I'm just going to pause the video and let you guys brainstorm it. Okay, so who found it? Yell it. Beautiful. Okay, good. Now, 49 is the factor you want. Now, keep in mind, guys, that the 49 is inside the radical house, correct? It's 49 times 2? So the square root of 49 is 7. And the 2 is not perfect, so it has to stay. And then what can you do at the end with the product here? You just merge 3 and 7 to make 21. Okay. Now sometimes students will do the 49 and the 2. They'll get the 7 and the 2, but they'll forget about that 3. Don't forget that 3 is still there the whole time, okay? You can. That's the last column of the... No, that's making it less simplified. It's the last column. You're going mixed to entire on the whiteboard. Okay, let's take a look at this. This line, they want to find the distance of that line. So they just got to find the length of that line. To find the length of that line, all you have to do is the Pythagorean theorem. Because all it is, especially those that have taken physics, you know that this is just, especially those like in Science 30, you guys should know this for physics. This is just the x component and this is just the y component. Those components make like a ramp. Though that ramp, like if you've taken a science class, like you know that slope. You should know what slope is. We talked about it in the first unit. So what is this delta y here? How much did the y change by? What did the y go up by? How many units? Can you just count them? Yeah, it just went up by, I'm just going to switch color because it's kind of confusing here. So this delta y, I'm sure you can see that it's 3 units. You just count them. 1, 2, 3. That's the rise. Can you confirm with the ordered pairs? Like look at the y. It goes from -2 to 1. Like if the temperature was -2 degrees Celsius and then it got hotter and then the temperature was 1 degree Celsius, how much did the temperature go up by? Went up by 3, right? So that's the change in the y. In a similar fashion, you can find the change in the x. What's the change in the x? Just count them up. Is it 9? Yeah, so from -6 all the way to 3, this is 9. Okay? So if you have the length of the right-angled triangle, you just do the Pythagorean theorem. So I'll just sketch it over here. Yeah, junior high for sure. Yeah, yeah. So this is 9, this is 3, and then they want you to find c. So c will equal, oops, c squared will equal 9 squared plus 3 squared. C squared is, what's 9 squared? 81. 3 squared is 9. So you get that c squared equals 90. So c squared equals 90. How to get c? Beautiful. You guys have been doing this a long time. Square root both sides. And you get that c is root 90. Now, that is definitely a doable for you guys. Now, what makes this harder is now you have to simplify this as a mixed radical. So now how do you simplify 90? So now you got to, which perfect square divides 90? Do you think 4 does it? Do you think 9 does it? Oh, 9. 9 definitely. Why? Because you just add, you tack on a 0 there. So 9 times 10 is 90. So we're going to switch this to square root 9, square root 10. And the square root 9 simplifies to a 3. And the 10 is not perfect. So this is final answer, 3 root 10. And you're not expected to use this distance formula. I don't care about that. You just do the Pythagorean theorem. That distance formula is exactly what we just did. You find the difference in the x's and square them, find the difference in the y's and square them. Because that formula is very powerful actually. Like it is the Pythagorean theorem in general. And that extends, you could do that for cubes, you could do that for 4-dimensional space too. Yeah, it's pretty cool. Alright. Now we're going to go the other way. So I'm just going to pause the video for a second. Okay, so converting, now we're going mixed to entire. The one that the book is doing is like how I did it on the top of the whiteboard there. We want to think to ourselves, okay, what would 4 look like if it was written as a square? So 4 goes with 16, and then we can merge the 16 and the 5. 16 times 5 is 80, right? We just did that. We just did that on the board. Is it? You're messing with me? Okay, so let's convert these ones. Alright, so I don't like doing it the way they do it. I just like to throw it inside and square it, personally, so I'm going to do it my way. So when the 2 goes inside, you will square it. 2 squared is 4. 4 times 6 is 24. Good. And if you don't know your times tables, like, it goes slower for sure, but just stick with it. Use your calculator to your best of your ability. And yeah, just be patient, I guess, if you don't know your times tables too well. Okay, now here for part B, there's like a twist. Like, it's like an M. Night Shyamalan movie or whatever. There's a twist. What's the twist for part B? What? There's a negative, yeah. Can you put the negative inside that square root? No, you cannot. We talked about that yesterday. You can't square root negatives. So all you gotta do is leave it on the outside. What goes inside? Just the 5 squared. Like, what does that negative on the outside even mean? It's just a negative 1. That's all it is. 5 squared is 25, and then 25 times 7, 175. Okay, and the negative just stays on the outside. Now for part C, like, a lot of you will like automatically shut down as soon as you see a fraction. But like, I'm not sure why. Like, it's just 2 on top of 3. Those are just integers. Just treat them as integers, just 2's on top of 3. Okay, so when it goes inside, I mean 2's on top of 3, so you're going to do 2 squared on top of 3 squared. Just do them separately. It's just 2 on top of 3. It's just integers like stacked on top of each other. That's all it is. Okay, so then what do we got here? 2 squared is 4. That's on top of 3 squared, which is 9. And then where does that 18 live? Is it on top or bottom? The 18. 18's on top, right? Like if you look, 18's on top of 1. If you need that. 2's on top of 3, 18's on top of 1. Usually that 1's definitely not written, usually. Okay, so the 18 just goes up top. And I have a lot of like extra of that, so I'm just going to clean that up a bit. And then like guys, it's just 4 times 18 divided by 9, which you could put in your calculator. However, you could also just think about this. 4 times 18, that's 36 times 2, which is 72. 72 divided by 9 is 8. Like, if you can't do that, try to go a different way. Go this way first. Like, what's 18 divided by 9? 18 divided by 9 is just 2. And then you have 2 times 4 is, this is square root 8. Or mostly like if you have to like add or subtract them. Yeah. Alright, and I'm not going to spend much time on this class example 10 because you're not going to get tested on this, and I know like a lot of you like probably don't care. I could show you one of them. Yeah. Like, if you did ever get this on a test, you guys, all you would have to do is type them in, like 3 root 5. Just type it in, 3 root 5. And then get the decimal, like 6.708. And then the next one's 5 root 3. So just like get the decimal. 8.66. So then you would say, okay, 5 root 3 is greater than 3 root 5. Yeah. Yeah. Okay. I'm not going to give you that test question, so I'm not too worried about it. What I am worried about though, you guys, is the mixed to entire and vice versa, the entire to mixed. And you will have those applications to Pythagorean theorem. Can we just do one cube before I set you free? The extension? Oh, they don't give me one? Okay, let's do cube root 40. Let's do cube root 40, but let's just do it on this white space over here. Cube root 40. So when you go to try to divide 40, guys, you cannot pick from the square list. Remember we're always using 4, 9, 16, and so on? Those are squares. We can't use those. So which ones are we going to use? The cubes. 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. Now for this question, 40, like clearly 27 and bigger, they're not going to work, right? So it's got to be 8. So we can change cube root 40 to cube root 8 multiplied by cube root 5. And then the cube root of 8 is perfect. It becomes 2. So it's 2 times the cube root of 5. Now I wrote that really big on purpose because what I find is students will get confused and unorganized because they'll write the index as large as the coefficient. So just make sure you write your index nice and small. Okay. So in terms of your homework, I'll put that back if you need it. Okay. So for your homework, like number 5, absolutely number 5. Whoa, what's going on here? My page doubled up somehow. Okay. Whoa, and I'm missing 6 and oh my gosh. Okay, so I'm not, okay. I'm just gonna look on my book. Okay, guys, for the assignment, 5, 6, and 8. $12. Okay, and then 13 and 14, these are the extension, and only the bravest will try these. Because I'll just, lots of the times you don't want to teach to the test, but like sometimes, like for a -2, I know that's, like, anyways, 95% of your exam will be squares, and squares only. So this extension is this is for cubes. So for like that, if you want to get 100%, you make sure you do 13 and 14. Okay? All right, so you're free. You guys can work.